Assalamualaikum warahmatullahi wabarakatuh. Abid to my panelists, Sir Muhammad Suhairil bin Meon and Dr. Noor Leha Binti Abdul Rahman, and to all of viewers. Today I am going to present about my final year project 2 with title Water Filtration to Xylem. My name is Ahmad Izzuddin bin Mohamad and I am the presenter of this video. My supervisor name is Madam Fauziah Muhammad Yusof. Please enjoy my video. Today's presentation is structured as follow outline. First, it is introduction. Second, problem statement. Third, objective. Fourth, scope of work. Fifth, literature review. Sixth, methodology. Seventh, result and discussion. Eighth, conclusion and recommendation. Introduction. It is about effective ways for providing safe drinking water are urgently needed to reduce the global burden of waterborne disease. This study will demonstrate that plant xylem from 3 different types of trees, which is a readily available, low-cost, biodegradable, and disposal material, can filter water by simple pressure-driven filtration. Approximately 3 cm3 of xylem can filter water at a rate of several liters per day, sufficient to meet the needs of one person for clean drinking water. The finding shows the ability of plant xylem to meet the need for pathogen-free drinking water in developing countries. Problem statement. The world is experiencing the scarcity of clean and potable drinking water. Thus, the increase in fresh water scarcity is leading scientists and environmentalists to develop a large-scale economical water filtration technologies. The result will demonstrate the potential of plant xylem to solve the need for pathogen-free drinking water in developing countries. There are several objectives of this experiment. First, it is to develop materials for water filtration. Second, it is to measure the flow rate of different types of xylem in filtering water. Third, to identify the effect of variation of xylem size in filtering water. Fourth, to determine the filterability of xylem in filtering water. Scope of work of this experiment are: first, the material used in this experiment are fresh leaves xylem obtained from pine, rambutan, and mango tree. Second, submersible pump was used to pass the water flow through xylem by pressure driven. Third, water flow rate was measured based on amount of filtrate collected in 60 seconds. Literature review. Need of clean water. Water is essential to the daily needs such as hydration, housework, and cooking, as well as environmental protection, sanitation, health, and possibly food safety. Therefore, water for drinking or drinking water is one of utmost importance in our daily life. In terms of method, there are many popular technologies for water disinfection, include chlorination, filtration, UV disinfection, pasteurizing or boiling, and ozone treatment. Chlorine treatment is successful on a wide scale, but it is becoming costly for smaller towns and villages. Boiling is an efficient method of disinfecting water. However, the amount of fuel needed to disinfect water by boiling is many times higher than that is used by a typical cooking family. In terms of xylem, there is a possible solution in the form of plant xylem, which is a porous material that conducts fluid in plant. Plants also develop advanced xylem tissues to bring sap from their root to their shoots. Xylem has developed under the conflicting pressure of providing limited resistance to the growth of sap while retaining tiny nanoscale pores to avoid cavitation. Methodology. First, it is material selection. Initially, xylem were obtained by cutting branches from selected trees, which are pine, mango, and rambutan trees growing in area of my village. These trees are chosen based on their categories that are angiosperm and gymnosperm. The branches of the tree were cut and the bark of the branch was removed to get the xylem only. Preparation of xylem as a water filter. Firstly, small suitable parts of the branch of the tree are cut into 6 cm long sections and approximately 2 cm in diameter pieces. The bark of the branch was removed and the piece of wood was inserted into one end of the pipe. Branch sections were fixed at the end of rubber tubing, secured with clamp and sealed by hot glue. Throughout the experiment, tap water was used. Then, spread tests were conducted by dissolving dyed blue coloring into tap water. Fabrication of experimental setup. A submersible pump of 20 watts in capacity is placed at the bottom of the plastic basin. The outlet of the pump is connected to a rubber tubing at the end of which xylem is fastened. Measurement of flow rate. Approximately 10 liters of tap water was filled in the container. 5 ml of blue ink was dissolved in it, and the solution was made to flow through the rubber tubing by applying pressure through a pump. The pump pressure varied from 1.5 per square inch to 2.5 per square inch for each set of reading. Before measuring the flow rate, the solution in the plastic basin was stirred to ensure proper mixed solution. For each reading, the water flow rate was calculated by observing the volume of filtrate collected in 60 seconds. Check filterability of xylem. 50 grams of mud was mixed in about 10 liters of tap water to obtain a turbid solution. This solution was passed through plant xylem under a constant pump pressure of 2.5 per square inch. Volume of filtrate was collected and carefully observed. To make the filterability more effective, 50 grams of SAM was inserted in the tube followed by xylem before the experiment is started. Result and discussion. Firstly, it is about the variation of flow rate. Based on this experiment, filtration of each of the 3 xylem were observed for respective flow rate, that is, rate at which filtrate was collected by varying the pump pressure. Result shows that at maximum pressure, the flow rate for each tree was maximum. Based on this table and figure shows that under a constant pressure, flow rate for pine was maximum, followed by mango and rambutan. Since pine belong to the class of gymnosperm, consequently they show greater performance. This shows that pine is the best suited for quick filtration. Mango and rambutan trees are flowering plants. Thus, as expected, they show poor flow rate and therefore are not suited for filtration. Effect of length over diameter on flow rate. Since pine xylem had the greatest filtration rate among of the 3 trees, its filterability was investigated further by varying the length and diameter. Pump pressure was constant at 2.5 per square inch. Firstly, readings were taken by fixing the length of the xylem at 6 cm and varying its diameter from 2 cm, 2.5 cm, 3 cm, and 3.5 cm. Secondly, the diameter was kept constant at 2 cm and the length was varied from 6 cm, 8 cm, 10 cm, and 12 cm. The formula to calculate the L/D ratio was given by dividing length over diameter. It can be seen from the table that flow rate decreased linearly with increasing length over D ratio. However, in the case of length kept constant and diameter varied, flow rate were considerably higher as compared to the case of varying diameter. Highest filterability was observed for pine xylem with a length of 6 cm and diameter of 3.5 cm, while it was least when the length was increased to 12 cm and diameter was 2 cm. Filtration performance of pine xylem for turbid water. Based on the two results above, have led to the conclusion that when freshly cut xylem from pine tree, which is 6 cm length and 3.5 cm diameter, was used for filtering water under a pressure of 2.5 per square inch, the filtration performance and flow rate is highest. The bit water was made to pass through pine xylem under the aforesaid condition. In figure, it was observed that xylem able to remove impurity incompletely. While in this figure, it was observed that the combination of pine xylem and sand was able to remove the impurity completely. This means that in the event of a natural disaster such as flood, where clean water is scarce, pine xylem could act as a potential water filter. Thus, to make it more efficient, combination of xylem and sand capable to filter the water completely to remove contaminant. Conclusion and recommendation. As a conclusion, the use of xylem in filtering element may be efficient and cost-effective, as tree is a renewable material that is available in many locations around the world. Based on this experiment, trees with needle leaf and naked seed like pine can filter ink and mud water. In addition, this type of plant belongs to the group of gymnosperm type. In this experiment also, xylem of the plant are found to show filtration property. To determine the optimal plant for filtration, the xylem of 3 different plants were evaluated for filtration of ink solution. Those trees were gymnosperm and angiosperm in type. The trees which flower and give fruits like mango and rambutan are angiosperm, and these fail to purify water and remove impurities. As for recommendation, there are several tests that must be carried out to screen various plants to identify the best filter. Then, more research could be done in future to improve the accuracy of xylem in filtering water. With this, I end my video presentation with the video how the experiment was running out. Thank you.